this lone pair of electron, nitrogen mele lone pair idiyalla, this it should be available to give the electron deficient species. Diazonium salt, first it will be converted to aniline, will be converted to diazonium salt. This diazonium salt, upon hydrolysis, it will give the what? Benzyl alcohol. But he is asking number of isomers possible for this A. When it comes to Ili, here there is no availability of the lone pair of electron. That's the reason these are the three maximum products, maximum number of molecules it can be reacted. Okay. Hello my dear friends, Elrigu Namaskara, myself Kodam Naveen Kumar, Nima Chemistry faculty. I welcome you back all to this incredible platform, Physics Wala. Now, here ನಾನು ಇವತ್ತು ನಿಮ್ಮ ಮುಂದೆ ಬಂದಿದ್ದೀನಿ with another KCET Super 30 analysis. Now, ಅದು ಯಾವ ಚಾಪ್ಟರ್ ಅಂದ್ರೆ now that is amines. Amines are organic compounds containing nitrogen. Now, ಈ ಚಾಪ್ಟರ್ ಇಂದ 2-3 ಕ್ವೆಶ್ಚನ್ಸ್ ಪಕ್ಕಾ ಬರುತ್ತೆ. Now, here in JEE Mains as well as NEET as well as KCET, but here we are going to see only concept on the KCET. Now, what type of the questions? Now, ಯಾವ ತರ questions ಕೇಳ್ತಾ ಇದ್ರು? Now, ಯಾವ ತರ questions ಕೇಳ್ತಾ ಇದ್ರು? ಯಾವ ತರ ಆ questions solve ಮಾಡಬಹುದು? ನಾವು ಎಷ್ಟು ಫಾಸ್ಟ್ ಆ ಕ್ವೆಶ್ಚನ್ ಸಾಲ್ವ್ ಮಾಡಬಹುದು ಅಂತ we are going to see in this video. Now, first question ನೋಡೋಣ. The first question ಏನಂದ್ರೆ the basicity of aniline is less than that of cyclohexylamine. This is due to basicity ಅಂತ ಕ್ವೆಶ್ಚನ್ಸ್ ಕೇಳ್ತಾ ಇದ್ರು. ಇಲ್ಲಿ ನೋಡಿ aniline ಅಂದ್ರೆ this is the aniline ಅಲ್ಲ, this is the aniline. Now cyclohexylamine, this is a cyclohexylamine. Now this is the aniline, this is the cyclohexylamine. ಇದರಲ್ಲಿ what is asking, the basicity of aniline is less compared to the cyclohexylamine. Aniline basicity is less. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ aniline ಗೆ ನಾವು basicity ಅಂದ್ರೆ ಏನು? ಮೊದಲು basicity ಅಂದ್ರೆ ಏನು? now available of lone pair, or this lone pair of electrons should be given to the electron deficient species. Now available of lone pair, ಇಲ್ಲಿ this aniline lone pair of electrons are participated in the delocalization. Aniline, this lone pair of electrons are participated in the delocalization. Due to the presence of this delocalization, now availability of lone pair of electrons and the aniline will not be present. ಇಲ್ಲಿ ನೋಡಿ the cyclohexylamine lone pair of electrons are easily available to give to the any electron deficient. ಅದಕ್ಕೋಸ್ಕರನೇ aniline basicity is less. Now here it see now plus or effect of NH2 group. Now ಇಲ್ಲಿ ನೋಡಿ this NH2 amine group will comes under the plus R group and the minus I group ಅಲ್ಲ. plus R and minus I ಇದರಲ್ಲಿ ಯಾವುದು dominating? plus R is more dominating. plus R effect of the NH2 group, due to the plus R effect of NH2 group, this is having the least stable, least basicity, least basic. Okay. Next, which of the following would undergoes Hofmann reaction to give the primary amine? Now here Hofmann reaction ಅಲ್ಲಿ ಒಂದು descent of carbon ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ first Hofmann reaction mechanism ಏನಂದ್ರೆ here this is the acid amide. Now in the presence of Br2 and aqueous NaOH or any base, aqueous NaOH or base. Now first what it will do, now this is the base mechanism. Now base ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ this proton it will be abstract, this NH2, this acid amide it is having the proton alla, this proton it will be abstracted by the which one? Sodium is a strong base. it was abstracted by the base. Now here we will get the negative charge. Now this negative charge, it was abstracted by the Br. Now this will be abstracted by this Br, and this Br will be eliminated. Now, R, C double bond O. Now N, H, and this is a Br. Now again we are having the base. Again we are having the base. Now base, again this abstract this proton. Again we'll get the C double bond O. Now NH, and this is the Br. NH, and this is a Br. Now what happens? Now this negative charge will be delocalized here. Now this pi bond will be shifted toward this oxygen. Now R, C double bond O minus, now double bond N, Br. Now again this negative charge will be delocalized, and we'll get the primary carbon ion is a stable, alla? Primary carbon ion is stable. Now we'll get NBr. Now here we'll get the double bond O, and we are having the R minus. Now this primary carbon ion will go and abstract to this nitrogen, and the Br will be eliminated. Br will be eliminated, and we'll get the okay. Now here we are having the hydrolysis. Now this will go and abstract here. Now this, it will be shifted towards the nitrogen. So what we'll get? Oxygen, it is having the positive charge. Now here we are having N and R. Now to stabilize this positive charge, this sigma bond will be shifted toward this oxygen, and this positive H plus will go and attack here. ಇದರಲ್ಲಿ ಸೇಮ್ ಏನಾಗುತ್ತೆ? Same there, this sigma bond will be delocalized here. Now this sigma bond will be shifted towards the nitrogen, and this positive charge again it will go and attack here, and we'll get the primary amine plus CO2. Primary amine and the CO2. ಇದರಲ್ಲಿ ನೋಡಿ, here ಇದರಲ್ಲಿ ನೋಡಿ, now reactant side ಅಲ್ಲಿ ಒಂದು ಕಾರ್ಬನ್ ಇದೆಯಲ್ಲ, when it comes to the product, one descent of carbon ಆಗಿದೆ. Okay? Now which of the following would undergo Hofmann reaction to give the primary amine? ಯಾವುದು? Option number C. Acid amide is a reagent. Sorry, acid amide is a reactant we are going to use. Okay? Next. Alkali halide reacts with the alcoholic ammonia in a sealed tube, then the product formed will be. ಇಲ್ಲಿಂದೆ the products formed will be ಅಂತ ಕೇಳ್ತಾ ಇದ್ರು. Alkali halide. Here this is alkali halide in the presence of ammonia. This will react with the SN2 mechanism. Now this ammonia lone pair of electron idrali, this will be attacked from the alkali from the back side, and these halogens are the good living groups alla. Now this will be eliminated from the front, and we'll get the R. Now nitrogen has given the lone pair of electrons to the alkali alla, adugoskara nitrogen is having the positive charge. Now to stabilize this positive charge, now this sigma bond pair of electrons will be given to the nitrogen, and we'll get the primary amine. ಮತ್ತೆ ಈ primary amine ಏನು ಮಾಡುತ್ತಂದ್ರೆ, again this primary amine again it will be react with the alkali halide. Now this primary amine again it will be attacked to the alkali, and this halogen will be eliminated. Halogens are the good living groups alla. Now here we will get ಏನು ಬರುತ್ತೆ? Secondary amine ಬರುತ್ತೆ. ಮತ್ತೆ ಇನ್ನೂ this secondary amine, again this secondary amine it will be react with the alkali halide. Now here we will get the tertiary amine. here you will get the tertiary amine. Now primary amine, secondary amine ಮತ್ತೆ tertiary amine. Now here the products formed will be tertiary amine, secondary amine, primary amine, mixture of all these three. Mixture of all these three. Okay. Next. Amines behaves as. Amines behaves as. Amines andre. This is amines alla. Amines. Now amines, it is giving the lone pair of electrons alla. It is giving the lone pair of electrons to the electron deficient species. Electron deficient ge electron kodda idalla. If this electrons is giving, it is acting as a Lewis base. Lewis bases. Now Lewis bases andre electron donors. Electron donors are the bases. Electron acceptors. Electrons acceptors are acids alla. These are acids. Now idu bases. Means he is asking the primary amine. Primary amines are the aprotic acid alla. Neutral compound. Lewis acid. Lewis acid andre electron should be accepted. It is electrons are giving. So in the Lewis base. Lewis base. Amines have behaves as a Lewis bases. Okay. Next. Arrange the following in the increasing order of their basic strength is. Now ಇಲ್ಲಿ ನೋಡಿ basic strength. This type of the question when they ask ಈ ತರ ಈಗ question ಕೇಳಿದ್ರು ಅಂದ್ರೆ here there will be somewhat tricky concept ಇರುತ್ತೆ. Now what is that concept? ಇಲ್ಲಿ ನೋಡಿ CH3, this is primary amine. Next we are having the secondary amine. Next we are having the tertiary amine. Next we are having the NH3. ಇದರಲ್ಲಿ which is the strong base ಅಂತ ಕೇಳ್ತಾರೆ. ಇಲ್ಲಿ ನೋಡಿ this lone pair of electron, nitrogen ಮೇಲೆ lone pair ಇದೆಯಲ್ಲ, this it should be available to give the electron deficient species. Again when this nitrogen will get the positive charge, that is stabilizing by the plus I groups. Methyl will comes under the plus I groups ಅಲ್ಲ. Means ಇಲ್ಲಿ ನೋಡಿ here this is primary, this is secondary, this is tertiary and the normal ammonia. Now ಇದರಲ್ಲಿ which is the strong base ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಇಲ್ಲಿ ನೋಡಿ we are having the three plus I groups. Here we are having the 2 plus I group. ಇಲ್ಲಿಂದ 2 plus I groups ಇದೆ, ಇಲ್ಲಿಂದ 3, here it is the 1 ಅಲ್ಲ. But ಇಲ್ಲಿ ನೋಡಿ compared to the secondary amine and the tertiary amine, secondary amine is more basic. Secondary amine is a more basic. Now ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ secondary amine ಗೆ this lone pair of electrons which are present on the nitrogen, it can readily give to the electron deficient species. And here we are having the 2 plus I group. The 2 plus I groups ಏನು ಮಾಡ್ತಾ ಇದ್ರು? It is stabilizing that positive charge on the nitrogen. But when it comes to the tertiary, ಈ tertiaryಯಲ್ಲಿ ಜಾಸ್ತಿ plus I groups ಇದೆ. Electron donating capacity ಜಾಸ್ತಿ ಇದೆ. But here this lone pair ಕೊಡೋಕೆ, if the any electron deficient in the aqueous solution, if it is a H plus, now this lone pair of electron to give to the positive charge, due to the bulkiness of these plus I groups, now lone pair to give to the H plus, it will be decrease. Only the electron donating capacity it is there, but this negative charge to give to the plus I, it is decreased due to the bulky size of this one. That's the reason its basic strength is less compared to the primary amine. ಈ primary amine ಗೆ now lone pair of electrons is giving to the, this lone pair of electron will readily give to the H plus. Electron deficient species, it can give, and this is stabilizing by the plus I. But ಇದರಲ್ಲಿ only the plus I groups is present, but this lone pair of electron to give to the solution, it is not available due to these bulky groups. ಅದಕ್ಕೋಸ್ಕರನೇ this is having the less basic compared to the primary. The next will be the CH3 NH2. Next it will be the CH3 and the last will be the ammonia. The last will be the ammonia. What is the answer? Option number A is correct. Option number A is correct. Okay. Now this type of the questions ಈಗ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ನೀವು questions ಚೆನ್ನಾಗಿ ನೋಡಬೇಕು. Okay. Now next. Now CH3 CH2 Br. Now on the aqueous KOH and A it gives A, KMnO4 plus H plus gives rise to B upon NH3 it gives and C upon this is Br2 alkali. Actually Br2 alkali it will gives D. The D is asking. You notice this is first is ethyl bromide. Ethyl bromide under aqueous KOH andre K plus OH minus irutte. K plus OH minus irutte. Andre here the KBr it will be eliminated and it will A will be the ethanol. A will be the ethanol. Ethanol upon strong oxidizing agent. KMnO4 is a strong oxidizing agent. Now what it will do? Now primary alcohol it will be converted into carboxylic acid. Primary alcohol will be converted into carboxylic acid. Here these and nano alcohols, phenols, ethers ಅಲ್ಲಿ ನಾನು ಸೇಮ್ KCET ಮೇಲೆ ಸೂಪರ್ 30 ಕ್ವಶನ್ ತಗೊಂಡಿದ್ದೀನಿ. ಅಲ್ಲಿಂದ ನಾನು ಈಗ ರಿಡಕ್ಷನ್ ಟೇಬಲ್ ಮತ್ತೆ ಆಕ್ಸಿಡೇಷನ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ನಾವು ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಟು ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್. ಈಗ ಇಲ್ಲಿಂದ PCC ಇದೆ ಅಂದರೆ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಟು ಆಲ್ಡಿಹೈಡ್ ಅಂದು ಚಾರ್ಟ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ನಿಮಗೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆ ಅಂದರೆ ಆ ವಿಡಿಯೋ ಹೋಗಿ ನೋಡ್ಬೇಕು. ಯು ಕ್ಯಾನ್ ಸಿ ಓವರ್ ದೇರ್ ಇನ್ ದಟ್ ವಿಡಿಯೋ. ನೆಕ್ಸ್ಟ್ ಹಿಯರ್ B ಅಲ್ಲ, this is B, this is A. Now B upon when it is reacting with ammonia, now what we'll get the acid amide. Now this is a C. Now C upon Br2 in the presence of aqueous alkali. This is half-mind bromide reaction. Half-mind bromide reaction ಅಲ್ಲಿ descent of one carbon ಆಗುತ್ತಲ್ಲ, it is give the primary amine. Option number C. Okay. Next. Which one of the following forms propane nitrile as the major product? Ilinda is asking propane nitrile as the major product. This is a propane nitrile. Now propane nitrile as a major product. This is a propane nitrile. See ಇಲ್ಲಿ ನೋಡಿ, if you take the ethyl bromide, this is ethyl bromide upon alcoholic KOH, alcoholic KCN. Next, if you take ethyl bromide alcoholic KCN, ಈಗ alcoholic KCN ತಗೊಂಡಿದ್ರೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? what it will do? Now here KCN it will be eliminated. Now again it will give the CH3 CH2 and it will give the as a KBr it will be eliminated and the cyanide will be attacked. So the option number 1 it will be answer. Okay. Next, the conversion of M-nitrophenol to the resorcinol in which of the following? Here is asking conversion of M-nitrophenol. M-nitrophenol andre this is meta, this is phenol, meta position alli nitro group into resorcinol andre how to convert this one from the M-nitrophenol in the resorcinol ge heng convert ಮಾಡಬಹುದು ಅಂದ್ರೆ ಈಗ ನೋಡಿ ಫಸ್ಟ್ M-nitrophenol ನಾವು ಏನು ಮಾಡಬೇಕಂದ್ರೆ ಫಸ್ಟ್ ಇಲ್ಲಿ ನೋಡಿ first we have to do what we have to do first M-nitrophenol ಇಂದ resorcinol ಗೆ ಫೈಂಡ್ ಮಾಡಬೇಕಂದ್ರೆ first we have to do ರಿಡಕ್ಷನ್ ಮಾಡಬೇಕು. ರಿಡಕ್ಷನ್ ಹೆಂಗೆ ಮಾಡಬೇಕು? tin in the presence of HCl ಏನಾಗುತ್ತೆ? It will convert nitro into aniline. It will convert nitro into aniline. Now, after the conversion of nitro into aniline, now next ಏನು ಮಾಡಬೇಕಂದ್ರೆ NaNO2 plus HCl. Now diazotization to 0 to 5 degree. Now ಏನಾಗುತ್ತೆ? Now amine group will be converted into diazonium salt. It will be converted into diazonium. Now upon hydrolysis, elimination of the diazotization, it will take place and we'll get the OH group here. We'll get the OH group here. First what we did? Reduction. First we did the reduction. Next diazotization. Next hydrolysis. Option number D is correct. Option number D is correct. Next. Benzylamine is stronger base than the aniline because of. ಈಗ ಇಲ್ಲಿ ನೋಡಿ benzylamine. This is the benzylamine. This is the benzylamine. Is stronger base than the aniline. This is the aniline. This is the benzylamine. That is the aniline. Now basicity ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ಬೋದು? ನಾವು ಈಗ ಇಫ್ ನೈಟ್ರೋಜನ್ ಮೇಲೆ ಲೋನ್ ಪೇರ್ ಅವೈಲಬಲ್ ಇದೆ ಅಂದ್ರೆ, ಅವೈಲಬಲ್ ಡೊನೇಷನ್ ಮಾಡೋಕೆ ಅವೈಲಬಲ್ ಇದೆ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್. ಇಲ್ಲ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಅ ವೀಕರ್ ಬೇಸ್. ಇಲ್ಲಿ ನೋಡಿ ಅನಿಲಿನ್ಗೆ ದಿಸ್ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಹ್ಯಾಸ್ ಪಾರ್ಟಿಸಿಪೇಟೆಡ್ ಇನ್ ದ ಡಿಲೋಕಲೈಸೇಷನ್ ಅಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರನೇ ಅನಿಲಿನ್ ಇಟ್ ಈಸ್ ಅ ವೀಕರ್ ಬೇಸ್. ನಾವು ಇಲ್ಲಿಂದ ನೋಡಿ ಬೆಂಜೈಲಮೈನ್ ಅಲ್ಲಿ nitrogen lone pair of electrons is available to give the electron deficient species, ಅಲ್ಲಿಂದ ಅದಕ್ಕೋಸ್ಕರನೇ benzylamine is stronger base. Benzylamine is a stronger base than the aniline because the lone pair of electrons on the nitrogen atom in the benzylamine is delocalized. Lone pair of electrons on the nitrogen atom in benzylamine is, ಇಲ್ಲಿ ನೋಡಿ benzylamine ಅಲ್ಲಿ ಏನಾದರೂ lone pair of electrons are participating in the delocalization. Here this carbon is a sp3 hybridization. If the carbon is sp3 hybridization, there is no availability of p orbital. There is no accept of electron. Illi it is not participating in the delocalization. Option number 1. The lone pair of electrons on the nitrogen atom in aniline is delocalized. Yes. No. The lone pair electrons of the aniline is delocalizing. Lone pair of electrons on the aniline on the nitrogen, it is delocalizing. Adigoskarané option number B is correct. Option number B is correct. Okay. Next. An aromatic compound A on reaction with NaNO2 HCl at 0 degrees forms benzyl alcohol and nitrogen gas. The number of isomers possible for the compound A. Compound A ಗೆ number of isomers are possible for this one is asking. Isomers ಅಂದ್ರೆ ಸೇಮ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಇರಬೇಕು, ಬಟ್ ಡಿಫರೆಂಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಇರಬೇಕಲ್ಲ. ಇನ್ ಸೇಮ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಇಟ್ ಶುಡ್ ಬಿ. ಫಾರ್ಮುಲಾ ಶುಡ್ ಬಿ ಸೇಮ್. ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್, ನಂಬರ್ ಆಫ್ ಹೈಡ್ರೋಜನ್, ನಂಬರ್ ಆಫ್ nitrogen should be same, but the structure should be different. Okay, that we call it as a isomers. Means here C7H9N, C7H9 andre this is a, actually this is a primary amine. Benzylamine ಇಲ್ಲಿ ನೋಡಿ C7 ಅಲ್ಲ, benzene it is having the 6 carbons. ನಾವು ಇದರಲ್ಲಿ ಒಂದು ಕಾರ್ಬನ್ 7. now hydrogens ಎಷ್ಟು 9, benzene ಮೇಲೆ 5, here it is 2, 7, here 9, ಒಂದು nitrogen, one nitrogen. now this is a upon NaNO2 plus HCl at 0 degrees, it will give the benzyl alcohol. Upon hydrolysis, first it will be converted into diazonium salt. First it will be converted into aniline, will be converted to diazonium salt. This diazonium salt upon hydrolysis it will give the what? Benzyl alcohol. But he is asking number of isomers possible for this A. number of isomers possible for this one. This is one isomer. Now B isomer ಹೆಂಗ್ ಬರ್ಬೋದು ಅಂದ್ರೆ CH3 and this is at ortho position 1. Same molecular formula. ಇಲ್ಲಿ ನೋಡಿ how many hydrogens? 1 2 3 4. Here one hydrogen, here one hydrogen, here one hydrogen, here one hydrogen. 4 hydrogens, 5 6 9 hydrogens, carbons is to 7 nitrogen. Same molecular formula, different structure alla. So this is 2. Now 3. Now at meta position, this is C, this is 3. Now fourth one, para position 1, para position 1. Now this is D. Now 1 2 3 4, and the next is also, another one is also possible. Now this is also possible. Here the 5 6 and this is 9. Same. How many total? 1 2 3 4 5. 5 isomers are possible for this one. Option number A. Option number A. These are the 5 isomers possible for this one. Okay, next. Here the P upon Grignard reagent gives rise to R. Now R upon dilute NaOH upon heating, it is giving 4 methyl pent 2 in 2 on is asking. 1 2 3 4 5, 4 carbons alla, 5 carbons pent, and is asking 4 methyl. Let's take this is the fourth position and 3 in and the 2 on. Now this should be formed. Now the P is asking, the P is ethane nitrile. Ethane nitrile is a P. How andre yakandre illi nodi CH3. Now this is the ethane nitrile. Ethane nitrile upon Grignard reagent. Ethane upon Grignard reagent upon hydrolysis. Now Grignard reagent alli metal is the electropositive and the R will be the negative, right? Now this it will be attacked over here. Now this it will be pi bond will this pi bond will be shifted toward this nitrogen. Now here we'll get the CH3 C and CH3 double bond N Mg Br. Now upon hydrolysis, here the oxygen will be attacked to this carbon and the remaining H2, here it will get the OH will be here, sorry. Upon hydrolysis, here you can do, here the one oxygen will be attacked here and the 2 hydrogens will be attacked towards the nitrogen. Now we will get the acetone. Here we will get the acetone. Now R is the acetone. Acetone upon dilute NaOH. This is the aldol condensation. This is aldol condensation. Now ನಾನು ಶಾರ್ಟ್ಕಟ್ ಹೇಳ್ತೀನಿ. aldol condensation ಕ್ವಶನ್ ಈಗ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ಹೌದು ಯಾವ ತರ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು, ಎಷ್ಟು ಫಾಸ್ಟ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, aldol condensation ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ಈಗ 2 moles of reactant. This is acetone. Now another mole of the acetone, its alpha hydrogen and the oxygen will be eliminated from here. Now idralli alpha hydrogen, functional group adjacent carbons are the alpha carbons, right? Now it is having the hydrogens, alpha hydrogens from here. Here the CH3, here the CH3, here the double bond. Now from the alpha hydrogens, 3 hydrogens idiyalla, C double bond O and the CH3. Now as the H2O it will be eliminated, and the product will be CH3 double bond CH, C double bond O, CH3. Same alla here and the here it is the same, right? here and here it is the same, right? Now CH3, now here this is 2 position, this is 3, this is 4, 4th position methyl, 3rd position ene, 2 position one, 3 position one. So option number C is correct. Option number C is correct. Next. In the given set of the reaction, 2-bromopropane, no, first alcoholic AgCN and the lithium aluminum hydride reduction. No, 2-bromopropane. This is 2-bromopropane. 2-bromopropane upon alcoholic AgCN upon heating. No, enagutte? We'll get the cyanide. We'll get the cyanide. Cyanide upon lithium aluminum hydride. We'll get the alcoholic AgCN, we'll get the isocyanide, sorry. We'll get the isocyanide. We'll get the isocyanide. AgCN, it is a covalent. This is AgCN, the bond between the Ag and the Cl is a covalent bond. Adhikoskarane, the attack will be takes place from the nitrogen end, and we'll get the isocyanide. Isocyanide upon lithium aluminum hydride. This is reducing agent and it will be converted into NCH3. Now this will be the N-methyl propane 2 amine. N-methyl propane 2 amine is the answer. N-methyl propane 2 amine. This is the IUPAC name of the Y. IUPAC name of the product Y. N-methyl propane amine. This will AgCN. If it is a KCN, the attack will be takes place from the carbon end. If it is a AgCN, the attack will be takes place from the nitrogen. Okay. Next. In the sequence of the following reaction, the starting compound P is asking the starting compound P is. Here the starting compound, the P will be the P nitrotoluene. Yakandre here the P nitrotoluene yakandre illi nodi P nitro, this is P nitrotoluene. P nitrotoluene alla. P nitrotoluene upon, this is Br2. Now upon Br2, this P nitrotoluene is meta directing group. Now here the methyl is a plus I and this is a ortho and the para directing group alla. This is a ortho and the para directing group. Andre here the Br2, it will be having the Br electrophile. Br electrophile will go and attack here. The Br electrophile will go and attack here. Okay, because here the NO2 is a meta directing group. For the NO2, this position is a meta. CH3 is a ortho para directing group alla. Now for this CH3, this is a ortho position. Now SN in the presence of HCl, nitro group will be converted into aniline alla. That is reduction madutte. Okay, now here it is a aniline. This is aniline. Now here NaNO2 in the presence of HCl, enagutte diazotization. Diazonium salt upon H plus, it will give the diazotization. Now H2 in the presence of H3PO2, the H plus it will give. No, enagutte orthobromotoluene upon KMnO4. KMnO4 upon reducing oxidizing agent enagutte carboxylic acid. It will get the carboxylic acid. So that's the reason P nitrotoluene. Iga M nitrotoluene tagondidu andre M nitrotoluene. This is CH3. Now this is M nitrotoluene. Iga M nitrotoluene tagondidu andre the Br2 will be attacked at which position? Br2 will be attacked at here, the Br. But when it comes to the CH3, CH3 is a para-diuretic group alla, ortho para-diuretic group, but for this CH3 it is, for this CH3 it is meta position. Adikoskarane A is wrong. Orthonitrotoluene if you take, orthonitrotoluene if you take, orthonitrotoluene if you take, for this position this will be the, for this position this will be the, which one? This one will be the, this one will be the, for this one, for the alkali group, this is the para-diuretic group. For the NO2, this is the meta-diuretic group. Okay, this can be formed. Idunu form agutte. But already they have given, already they have given some compound alla. Now benzoic acid plus and the at ortho position bromide alla. If you take this bromine here, if you take this nitro group here, now here will not get this product P, will not get this product, last product. If you take the ortho bromotoluene, it will not give. Okay, next one. One of the following amides which will not undergo the off-mind bromide reaction. Off-mind bromide reaction, this concept questions they are asking repeatedly in the KCET. This is a previous year KCET questions also. Now some of the KCET previous year questions also there. The plenty of the questions ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆನೆ ಕೇಳ್ತಾ ಇದ್ರು. ಅದು ಯಾವ್ದು ಕಾನ್ಸೆಪ್ಟ್? ಆಫ್-ಮೈಂಡ್ ಬ್ರೋಮೈಡ್ ರಿಯಾಕ್ಷನ್. ಆಫ್-ಮೈಂಡ್ ಬ್ರೋಮೈಡ್ ರಿಯಾಕ್ಷನ್ to be happened, it should have the primary amine. It should have the primary amine. ಅಲ್ಲಿ ಆಫ್-ಮೈಂಡ್ ಬ್ರೋಮೈಡ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಒಂದು ಡಿಸೆಂಟ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಗುತ್ತೆ. one carbon will be less in the product. Okay, off-mind bromide reaction, it should have the primary amine alla. Now when it comes to B, it is having the primary amine. CH, this is CH3, CH3, CH2, C double bond O, NH. Now here it is having the primary amine. Now if you take this one, now here also it is having the primary amine. Now if you take this one also, actually this is CH3. Now this is also having the primary amine. I think something they have given wrong. This is C2H5. C2H5. Now when it comes to the option number 1, CH3, C double bond O, NH and the CH3. This is not the primary amine. This is not the primary amine. It will not give the off-mind bromide reaction. It will not give the off-mind bromide reaction. Okay. Next. Maximum number of molecules of the CH3I. Now this is in the form of alkali halide alla, that can react with the molecule of primary amine. Molecule of primary amine. What it will give? Maximum number of molecules. See, this is CH3I. Now here we are having the primary amine. Now this primary amine, it is having the lone pair of electrons alla. This lone pair of electrons will be given to this CH3, and the iodine is a good leaving group. It will follow the SN2 mechanism, and it will give the, what it will give? It will give the secondary amine. It will give the secondary amine. Now again this secondary amine, what it will do? Again this secondary amine, sorry. Again this secondary amine, again it will be reacted with the CH3I. Now iodine is a good leaving group. Again it will form the tertiary amine. Again this tertiary amine, again it will be reacted. Again this tertiary amine, again it will be reacted with the alkali halide or methyl iodide. Now again it will be reacted and it will be gone. Now it will form the tertiary CH3, and this is the CH3, and this is a positive charge. Now there is no the availability of the lone pair of the nitrogen. Now the reaction will be stopped here. Now the maximum number of molecules that can be reacted with the molecules of CH3NH2R. How many? 1, 2, 3 alla maximum 3. Here there is no availability of the lone pair of electrons on the nitrogen. You know, here the availability of the lone pair of electron, that's the reason it is reacting. Now when it comes to this one, here the availability of lone pair ide, adikoskara it is reacting with the alkali halide. Now illinda no nitrogen mele lone pair of electrons is adikoskara it is reacting with you. But when it comes to illi, here there is no availability of the lone pair of electron. That's the reason these are the 3 maximum products, maximum number of molecules it can be reacted. Okay. Next. The reaction of the benzene diazonium chloride with aniline yields yellow colored dye. The name of the yellow colored dye will be, now that is a para amino azobenzene. Para amino azobenzene. This is a para amino azobenzene. This is a para amino azobenzene. Now here this is a which one? Yellow color dye. This is a coupling reagent, yellow color dye. This is yellow color dye. If this benzene diazonium salt, if it is reacted with the phenol, it will give the orange color dye. This will give the orange color dye. Now this is a para hydroxyazobenzene. This is a para hydroxyazobenzene. This is a para hydroxyazobenzene. This is a orange color dye. This is orange color dye. This is a yellow color dye. But as for this question, para amino azobenzene. This is a para amino azobenzene. This is a coupling reaction. Next. Now, Hofmann bromide reaction is converted to. Hofmann bromide reaction is converted to. Hofmann bromide reaction ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ? ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ? ಆಸಿಡ್ ಅಮೈಡ್ ಇಂದ ಆಸಿಡ್ ಅಮೈಡ್ in the presence of Br2. Now 4 moles of base. Now it will be converted into primary amine alla. It will be converted into primary amine. Hofmann bromide reaction ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ? ಅಮೈಡ್ ಇಂದ ಅಮೈನ್ಗೆ, ಅಮೈಡ್ ಇಂದ ಆಸಿಡ್ ಅಮೈಡ್ ಇಂದ ಅಮೈನ್ಗೆ. ಓಕೆ. Next. Now the correct sequence of the reaction convert p-nitrophenol to the quinol. You know, he is asking p-nitrophenol. This is p-nitrophenol. Now p-nitrophenol in the is asking quinol. Quinol andre this is a quinol. Now what are the process we have to do to convert into the quinol? First ಏನು ಮಾಡಬೇಕು? First we have to do the reduction. First we have to do the reduction. SN in the presence of HCl. Now ಏನಾಗುತ್ತೆ? It will convert NO2 into the aniline. It will be converted into the aniline. Now aniline after NaNO2 plus HCl 0 to 5 degree. Now ಏನಾಗುತ್ತೆ? aniline will be converted into diazotization. It will be converted to diazotization. Now it will be converted into diazotization. Diazotization upon hydrolysis. Diazotization upon hydrolysis will get the resorcinol. Will get the resorcinol. So reduction, diazotization and the hydrolysis. So option number A. Option number A. Okay. Next. Which one of the following gives amine on heating with amide? Which one of the following will gives amine upon amide? Now this is also Hofmann bromide reaction only. Amide upon, now you can ನೋಡಿದ್ದೀವಲ್ಲ, Br2 in the presence of aqueous KOH gives the amine. ಇದು ಯಾವುದು? Hofmann bromide reaction. ಅಂದ್ರೆ Br2 in the presence of aqueous KOH. Br2 in the presence of aqueous KOH. ಇಲ್ಲ, ಇಲ್ಲಿ ನೋಡಬೇಕು alcoholic KOH. It is not the alkali KOH, only the aqueous KOH. Next. No. in which of the following sequence of reactions, now is asking the compound A is, compound A ಯಾವುದಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ propane nitrile, ethane nitrile, nitromethane and the methyl isocyanate. ಇಲ್ಲಿ ನೋಡಿ no, once ethane nitrile, this is the answer is the ethane nitrile ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ CH3 CH. Now this is the ethane nitrile upon reduction, ethane nitrile upon reduction ಏನಾಗುತ್ತಂದ್ರೆ it will get the ethylamine. Now ethylamine upon the nitrous acid, it will give the primary alcohol, it will give the ethyl alcohol. Ethane nitrile is the answer. Ethane nitrile is the answer for this question. Okay, next. Organic compound A on reduction with compound A, on the organic compound A on reduction it will give the B, which on reaction with trichloromethane of a potassium hydroxide, the compound C on catalytic reduction, it will give N-methyl benzylamine. This is N-methyl benzylamine. This is the N-methyl benzylamine. Now on which one? Catalytic reduction. Upon B it will give the C upon catalytic reduction. C upon catalytic reduction it will give N-methyl benzylamine. Now the A will be the nitrobenzene. The A should be the nitrobenzene. ಯಾಕಂದ್ರೆ nitrobenzene upon reduction, what it will get? Will get the aniline. Now aniline upon the chloroform in the presence of KOH, aniline in the presence of chloroform in the presence of KOH ಏನು ಕೊಡುತ್ತೆ ಅಂದ್ರೆ isocyanate it will come, isocyanate in the presence of catalytic reduction ಏನು ಕೊಡುತ್ತೆ N-methyl benzylamine ಕೊಡುತ್ತೆ. That is a N-methyl benzylamine. Okay, the option is a nitrobenzene is a correct answer. Next, Innsbruck reagent is direct, this is the direct question. Benzene sulfonyl chloride is a Innsbruck reagent is used to identify the primary amine, secondary amine and the tertiary amine. ಯಾಕಂದ್ರೆ here Innsbruck reagent it will not react with the tertiary amine, it will react with only the primary amine as well as the secondary amine. Next, now the correct order of increasing basic nature of the bases, NH3 CH3 NH2, next is CH3 secondary amine, primary amine. Now we know, right? Primary amine, secondary amine, primary amine and the ammonia. This is the answer. Next, which of the following is more basic than aniline? Aniline ಇಂದ ಜಾಸ್ತಿ ಬೇಸಿಕ್ ಯಾವುದು ಅಂತ ಕೇಳ್ತಾ ಇದ್ರು ಇಲ್ಲಿ. ನಾವು aniline ಇಲ್ಲಿ ನೋಡಲ್ಲ, aniline ಅಲ್ಲಿ lone pair of electrons will participate in the delocalization. Now diphenylamine ಅಂದ್ರೆ this is a diphenylamine. Diphenylamine ಅಲ್ಲಿ lone pair of electrons has been delocalized into the two rings. Now triphenylamine This is triphenylamine. The triphenylamine alli lone pair of electrons has been delocalized in the 3 rings. The 3 rings. Next, p-nitroaniline. P-nitroaniline. This is aniline. But nitro group alla. But due to the presence of this nitro group, it will destabilize the lone pair of electrons on the nitrogen. Next, benzylamine. Benzylamine. Now, which of the following is more basic than the aniline? Here aniline, it is participating only the 1 ring. Here idರಲ್ಲಿ ಎರಡು, it is participating the 3 rings. When it comes to here, due to the presence of minus I groups, it will destabilize the lone pair of electrons on the nitrogen. But here the benzylamine, this lone pair of electron readily gives to the electron deficient species. Andike benzylamine is a correct answer. Benzylamine is a correct answer. Next. The correct sequence of the reactions to be performed to convert benzene into M-nitroaniline. Is asking benzene to M-nitroaniline. Benzene to M-nitroaniline. Sorry, M-bromoaniline. M-bromoaniline. Now, ಇಲ್ಲಿ ನೋಡಿ first benzene ಏನು ಮಾಡಬೇಕು? First nitration ಅಲ್ಲ, first nitration ಅಂದ್ರೆ concentrated HNO3 plus concentrated H2SO4. Now this will give the NO2 as the electrophile. It will be attacked to the benzene and will get the nitrobenzene. Nitrobenzene upon bromination. Nitrobenzene upon the bromination. Bromination ಅಲ್ಲಿ NO2 is a meta directing group ಅಲ್ಲ, meta directing group ಅಂದ್ರೆ here will get the meta group. Next we have to give the reduction ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? It will converted into aniline. It will be converted into aniline. Means first it is nitration, next bromination, last is a reduction. Okay. Next, which of the following will be most stable diazonium salt? Which of the following is most stable diazonium salt? Now ಇದರಲ್ಲಿ 4 ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವುದಂತ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಡೈಸೋನಿಯಂ ಸಾಲ್ಟ್ ಅಂತ ಕೇಳ್ತಾ ಇದ್ರು. ಇಲ್ಲಿ ನೋಡಿ, ನೈಟ್ರೋಜನ್ ಇಟ್ ಈಸ್ ಇನ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಲ್ಲ, means it requires the electrons. Here this is the plus I group, this is a mesomeric effect. Now ಈಗ ಸ್ಟೆಬಿಲಿಟಿ ಕೇಳಿದ್ರೆ ಮುಂಚೆ ಏನು ನೋಡಬೇಕು? ಫಸ್ಟ್ ಇಸ್ ಅ ಮೆಸೋಮೆರಿಕ್ ಎಫೆಕ್ಟ್. ಸ್ಟೆಬಿಲಿಟಿ ಇಫ್ ದೇ ಆಸ್, ಫಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಸಿ ದ ಮೆಸೋಮೆರಿಕ್ ಎಫೆಕ್ಟ್, ನೆಕ್ಸ್ಟ್ ಹೈಪರ್ ಕಾಂಜುಗೇಷನ್, ನೆಕ್ಸ್ಟ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ಅಲ್ಲ, ನೆಕ್ಸ್ಟ್ ಇಸ್ ಅ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್. ಇಯರ್ ದ ಮಿಥೈಲ್ ಗ್ರೂಪ್ಗೆ ಪ್ಲಸ್ ಐ ಎಫೆಕ್ಟ್ ಇರುತ್ತೆ, ಬಟ್ ಇಯರ್ ದ ವೆನ್ ಇಟ್ ಕಮ್ಸ್ ದ ಫಿನೈಲ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಪ್ಲಸ್ ಎಮ್ ಎಫೆಕ್ಟ್ ಅಲ್ಲ. ಸೊ ದಿಸ್ ಈಸ್ more stable diazonium salt. This is a more stable diazonium salt. But if you see here, this is a benzylamine. That's the reason it is compared to the, it is diazonium salt is directly attached to the benzene. It is stabilizing by the delocalization. Here there is no delocalization. Next question. Which one of the following is least stable in the water? Which of the following is least stable in the water? Actually this is benzylamine is the least stable in the water. ಯಾಕಂದ್ರೆ least soluble in the water. ಯಾಕಂದ್ರೆ ಇದರಲ್ಲಿ 3 it will form the hydrogen bonding. This will form the hydrogen bonding. This will retard the hydrogen bonding. That's the reason it is least soluble. Next. Now, if the aniline is treated with 1:1 mixture of concentrated HNO3 and the concentrated H2SO4, p-nitroaniline and the M-nitroaniline are formed nearly in the equal amounts. This is due to ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, if you take the aniline in the presence of concentrated HNO3 and concentrated H2SO4, these are the strong acids ಅಲ್ಲ, strong acids. Now strong acids ಏನು ಕೊಡುತ್ತೆ? H+ ಕೊಡುತ್ತಲ್ಲ. Due to the presence of this H+, nitrogen lone pair of electron will abstract this proton and it will form the ammonium ion. This will form the ammonium ion. This ammonium ion will be the meta directing group. Ammonium ion is the meta directing group. This is a meta directing group. Meta directing group. Meta directing group. See, protonation of the NH2 which causes the deactivation on the benzene ring. Here aniline is a ortho and para directing group. Due to the presence of this one, it is deactivating the benzene ring alla. It is activating as a, it is ring, this is ring activating group. Now by the presence of this one, it is acting as a ring deactivating group. Ring deactivation. So protonation of the NH2 which causes the deactivation on the benzene ring. This is ring activating. Due to the presence of this H plus, it will be converted into NH3 plus and it will deactivate the benzene ring. So option number. Now, which of the following has the lowest boiling point? Which of the following is having the lowest boiling point means here this is the ether is having the lowest boiling point due to absence of hydrogen bonding. Illinda option A, option C, option D alli hydrogen bonding irutte. Hydrogen bonding irutte due to the partial here CH3, CH2 and here the nitrogen and here the hydrogen and the hydrogen. Nitrogen is a more electronegative group compared to the nitrogen and the hydrogen. Nitrogen is a more electronegative group alla. That's the reason it is having the partial negative character, it is having the partial positive character. It will form the hydrogen bonding. It will form the hydrogen bonding in this manner. Now it will form the hydrogen bonding in the solution. It will form the hydrogen bonding in the solution. Remaining also will form the hydrogen bonding. Here there is no formation of the hydrogen bonding. Adhigoskarane it is having the lowest boiling point. Next. Now here NO2 nitrobenzene in the presence of Br2 bromination. Nitro is a yav group? This is minus I group alla, minus M group. Now this is a meta directing group. Meta directing group. Meta directing group alla means the P will be now meta bromo nitrobenzene. Meta bromo nitrobenzene. Now SNCl concentrated HCl and the reduction alla. Now this will be converted into aniline. And here it is a Br. Now NaNO2 in the presence of dilute HCl H2O it will be. Now this will be converted into diazonium salt. This will be converted into diazonium salt. Now this is a Br2. Br2 now upon hydrolysis what we will get? Now we will get the OH and this is a Br. Now what is the answer? What is the option number A? Option number A is asking R alla. R is the option number A. Phenol and the meta position Br. Phenol and the meta position Br. Okay. Next. By this we have finished our amines KCET mele ಯಾವ ತರ questions ಕೇಳ್ತಾ ಇದ್ರು ಅಲ್ಲಿಂದ all the questions I have brought and I cleared and I solved all the concept questions which they are asking in the KCET. These questions which I brought, these questions ನಾನು ತಂದಿದ್ದೀನಲ್ಲ, these questions all are from the previous year KCET questions only. Now ಈಗ ನಿಮಗೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆ ಅಂದರೆ ಕಾಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ. ಓಕೆ, ಬಾಯ್.